Welcome. In this video, I'm going to go over binomial coefficients and the binomial theorem. And by the end of the lesson, you should be able to, or when I say lesson, by the end of this video, you should be able to find binomial coefficients and apply the binomial theorem. So in the last series of videos, we were exploring counting, different methods of counting. We ended up right around permutations and combinations was the immediate video preceding this one. And let's focus on the concept of a combination. That is a selection of R items out of n things in which the order of the selection doesn't matter. And if you recall, a combination, n choose R, is equal to n factorial divided by R factorial divided by n minus R factorial. And this is a combination. So a combination can also be denoted like this, n on top of an R within parentheses. So this number, n choose R, is called a binomial coefficient because when binomial expressions, and that's an expression of this form, so a plus b to the nth power, are expanded, this number occurs as the coefficients of this expansion. So before we get more into the binomial theorem and figuring out binomial coefficients, let's discuss Pascal's triangle. And then finally, 3 choose 3 is just 1. Let's look at the fourth row, and it looks like I might be running a little low on space. So bear with me while I scooch things. There we are. So now things have been scooched a little bit. I think my diagonals are still visually there. There we are. But I've made some space to fill in my triangle more. So now I'm in the fourth row for this spot, the 0th diagonal, so this is 4 choose 0. Then I have 4 choose 1, 4 choose 2, 4 choose 3, and what do I finally have here in this last diagonal? Well, this diagonal was R equals 4, so I'm at 4 choose 4. And that translates to 4 choose 0 is 1. 4 choose 1 is 4, 4 choose 2 is 6, 4 choose 3 is 4, and 4 choose 4 is 1. Now if you don't see any of these, please use the side work here to work these out. So we can work out, say, 4 choose 2 is equal to 4 factorial over 2 factorial, 4 minus 2 factorial. So that's 4 times 3 over 2 is just 6. And if you don't see how I went from this step to this step, please see my last video on combinations. All right, so pause the video now and see if you can figure out the fifth row. And you're going to create the triangle twice as I have. In this triangle, you're going to leave the binomial coefficient unsimplified, that is, in its n choose R form. And here you're going to figure out the actual numerical value for this entire row. So please pause the video and see if you can figure out the fifth row. So we have 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. And so here 5 choose 2 is worked out to be 10, which is 5 factorial over 2 factorial times 5 minus 2 factorial, and that's how it works out to be 10. 5 choose 3 is symmetric, however. You can see how it works out to be symmetric here. This number is just going to be 3 factorial, which we have. Here, this number is going to be 2 factorial, so we'll get the same thing. And this is what the final version of our 5 rows of Pascal's triangle look like, highlighted so you can see the triangle shape. Now, let's discuss the binomial theorem. All right, let's go on with the binomial theorem. Let x and y be variables, and let n be a non-negative integer. Then what is x plus y to the n? Before I write out this formula, I want us to look at Pascal's triangle again. So as you can see here, I've sketched out Pascal's triangle really quickly, and just the numbers this time. But now on my first row, instead of 1 and 1, I'm going to put an x and a y. And then here in a light gray, let's put the plus sign there. Maybe that gray is too light. There we are, plus. So now, if you notice, the coefficients here are a 1 and a 1. This is 1x and 1y. So let's do the same for the next row. I have x squared, xy, y squared, and then I can put my pluses. And I'm missing a coefficient. I'm missing this 2 here. So let me go ahead and write that in. Now let's do the third row. For the third row, I'd have x cubed, 3x squared y, 3xy squared and y cubed. Can you see the pattern here? Let me do one more row and then we'll discuss the pattern a little more in depth. Here I have x to the fourth, 4x cubed y, 6x squared y squared, 4xy cubed, and then y to the fourth with plus signs all the way through. So let's see this pattern. The coefficients of these polynomials correspond to the coefficients here in Pascal's triangle: 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Additionally, let's look at the exponents. My exponent for the second row, 4x, starts off with a 2. This is the n equals 2 row, n equals 3, n equals 4 row. And the x exponents go down by 1. So we have 4, 3, 2, 1. And technically I have an x to the 0 here, since x to the 0 is just 1. Now what about the exponents on the y's? Well, the y's start off with y equals 0, with the exponent of 0. So y to the 0 is just 1, which is there. Then I have an exponent of 1, then 2, then 3, then 4. So the exponents on the x values are decreasing one at a time for every term, and the exponents on the y values are increasing one at a time for every term. And the coefficients correspond to the coefficients of Pascal's triangle. So please pause the video and see if you can figure out the fifth row of this expansion. You should have what I have here: x to the fifth, 5x to the fourth y, 10x cubed y squared, 10x squared y cubed, 5xy to the fourth, and y to the fifth. Binomial theorem. Let x and y be variables, let n be a non-negative integer, then x plus y to the n is equal to n choose n, x to the n, y to the 0, plus n choose n minus 1, x to the n minus 1, y to the 1, plus n choose n minus 2, x to the n minus 2, y to the 2. And let's keep going here, and I will rewrite this a little neater. And we'll keep going all the way to our final term of n choose 0, x to the 0, y to the n. And all of this simplifies to n choose n, x to the n plus n choose n minus 1, x to the n minus 1, y, plus all the way through n choose 0, y to the nth power. The only reason I added a bit more terms up above was so that you could really see that we have a y and we have an x throughout, but y to the 0 power is 1, x to the 0 power is 1, so they kind of disappear. The exponent on the x is decreasing by 1 and corresponds with this bottom number on the n choose r, so it corresponds to r, whereas the y exponent is always increasing, starting at 0 all the way through n.